Alright, so today we are doing FRQ number 6. Here is the time. Okay. Alright, so for part A, okay, well first it's given us a light bulb that's being hung by 2 wires that are 80 centimeters long. The light bulb weighs 0.25 kilograms. So I've already written it out, but you're gonna have your tensions and then your components of the tensions. So for part A, we need to find the tension in each wire. Okay, so we can go ahead and set up. Okay, so we can set up force, and since the light bulb is not going to be moving, that means our A is 0, so that cancels out, but you still have forces, so those are your Ty and your Ty, and then your F of G. So Ty plus Ty minus F of G, and that's going to be equal to 0. And then you can go ahead and rewrite that, so it's Ty plus Ty is equal to F of G. And then Ty, when you look at the angle, is sine, opposite, put your angle here, opposite, so sine. So T sine theta plus T sine theta is equal to mg. And then you can combine like terms, so you get 2T sine theta is equal to mg. Okay, so now at this point we have everything else we need except for theta. So we need to find theta. And what you can use to find theta is the law of cosines. And so and that looks like cos A is equal to B squared plus C squared minus A squared over 2BC. Okay. So let's rewrite this like this. So this is 0.8 meters. Oh. Take that back, We're gonna draw this. Okay, so this is gonna be our C, and that's 1. And then this will be A, and this will be B, and these are both equal to 0.8. Alright, so that's the triangle we're going to be using for our law of cosines. So cos A is equal to 0.8 squared plus 1 squared minus 0.8 squared over 2, 0.8, and 1. So these would cancel out. And then you get cos A is equal to 1 squared over 2.8, which is equal to 1. 0.8 times 2. So then you would have to take the inverse cosine. So you get A equals cos inverse of 1 over 1.6. So our theta is equal to 51.6 0.318. Okay, so now that we have our theta, we can go ahead and plug everything in. So 2t sine and our theta, 51.318. And our mass was 0.25, 9.8. And then just plug everything in. All right, and then we're solving for t. Newtons, and that is going to be the tension in both strings, because the tension is going to be equal because thetas are the same, the lengths are the same, so tension is the same. All right, moving on to part B. Part B wants us to find tension, but now it's accelerating upwards at 1 meter per second squared. So again, you can just set up force, but now our acceleration is 1, so we don't cancel that out, but we can expand it. And then you can combine everything. And then at this point, you can just go ahead and plug everything in. So we know that 2ty is equal to 1.56. And we know that f of g is equal to 2.45. And then our mass is 0.25, and our acceleration is 1. All right, so now you just do some algebra. And again, tension is going to be the same because the wires are the same length and they have the same angles. Okay, so now moving on to part C. Okay, so it says that the light was swaying too much, so you add 2 more wires, and those are fixed in the other corners. And so now it wants us to find the tension in each wire. I do not have a physical model set up, but we are going to draw out some diagrams to help us find our new theta. Okay, so let's go ahead and draw. So let's say we're like looking down, so kind of like this, but we're looking from the top right here. Your wires, okay, and your light would be right there. So you know that from here to here is 1 meter, and that from here to here is half a meter. And so now we need to find L, because even though the length of the strings or wires are 0.8 meters, they're bending, so that means that it's going to be shorter looking from the top. So we need to find L. So to do that, we are going to do, so we know that they're going to be 45-degree angles. So that means it's going to be sine 45 is equal to, so we're looking at this triangle right here. So this is our 45-degree angle right there. So sine 45 is opposite, so 0.5 meters over hypotenuse, which is our L, which is what we want to find. And so then we can go ahead and find L. So L would equal 0.5 over sine 45. So L would equal okay. So now what we need to do is draw another diagram, but this time we're looking from a side view. So this is top view, side. Okay, so you have that and then that. Okay, so this is our theta that we're trying to find. So this is L equals 0.707, and then this is our string. So this is 0.8. This would be our ty and our tx. Okay, so we want to find our theta, and using what is given, we can use cosine. So cosine theta is equal to, so adjacent 0.707 over 0.8. You can plug that in. (27.902 degrees). We'll just leave it as 27.9. Okay, so now that we have our theta, we can find the tension pretty much similar to this way, but now we have 4 strings. So let's go ahead and set up force. And for this one, again, it is not moving, but what we do have are 4 TYs minus F of G again, and that is going to be equal to 0. And then we can go ahead and move things around and combine, and you get 4 TY is equal to F of G. And then we know that 4 and then ty is sine theta is equal to mg. Okay, so we can go ahead and plug everything in. So 4t sine and our new angle of 27.9 is equal to, and we already know our f of g is 2.45. And then we can go ahead and solve for t. All right, so that is our new tension with the 4 wires. Again, the wires are all the same length, and the new theta is going to be the same for all of them, so tension would be the same. in all 4 wires. Okay. Okay, so now moving on to part D. Now part D wants the new scenario with the 4 wires, but now the elevator is accelerating upwards at 1 meter per second squared. And it wants us to find the new tension. Okay, so we can do what we've been doing. Set up force, but now there isn't an acceleration, so we leave it, but we already know that it's going to be equal to 4ty minus the f of g. So 4ty minus f of g is equal to ma. And then you have your 4t sine theta minus mg is equal to ma. And then we can just plug everything in, and we know it's 4t sine and our theta. And then we already know, again, our f of g is 2.45 is equal to, and our mass is 0.25, and it's accelerating at 1. And then we know that 4t sine 27.9 is 1.87t minus 2.45 is equal to 0.25. All right, and now we just need to solve for t. So we move 2.45 over. And solve for t. And again, tension is going to be the same in all of them because they're all the same length with all the same theta. And that is all. Here is our ending time. Of 2:30.